Okay, in today's about when Java development is started and who started this Java and when the previous versions are released and what's the latest version. We'll just discuss this history. And initially, the name of this programming language is also not Java. Initially, they have named it as Green Talk. Actually, there is a team called Green Team. So this team started doing research on developing a new programming language, and they have named it as Green Talk, and then they have renamed it as Oak. Oak is actually a tree. It's just a tree name. Initially, they have named this programming language as Green Talk, and then again they have renamed it as Oak. The initial versions, that means just the alpha and beta version, that is released in 1995. In 1995, just alpha and beta versions are released, and then the official release of Java is released in 1996 with the 1.0 version, and then 1.1 is released in 1997. Just a second. In 1997, Java 1.1 version is released, and in 1998, 1.2 versions with some latest features. From version to version, so there are new features added. And in Java 1.5 version, the most important features are added, and then in 1.6, 1.7, and 1.8, new features are added. So we'll discuss in detail when we discuss the concept. When we discuss the individual concept, we'll discuss in detail in which version that concept is introduced. We'll discuss everything in detail. And in 2000, Java 1.3 version is released. And in 2002, Java 1.4 version is released. And in 2004, Java 1.5 version is released. This version came with many important features. And then in 2006, Java 1.6 version is released. Do you know what's the current version of Java? Can you just tell me what's the current version? Any idea?
It's 1.8.
Yeah. In 2011, 1.7 is released. 1.8 is released in 2014. This is the simple history of Java. And we have already discussed about some of the important features, and we have discussed in detail about exception handling. Praveen, you have any idea on exception handling?
Yeah, actually, it ignores the errors which came on the programs which we do right now.
Is it to resolve compile time errors?
Yeah, I think, yeah, compile time errors.
Exception handling is not to deal with the compile time errors, it's actually to deal with the runtime exceptions.
Oh, okay.
Generally, we'll follow two steps, right? So first we'll compile our Java code and then we execute.
Yeah,
After compilation, a Dart class, yes. After compilation, a Dart class file will be generated, and then we'll execute that Dart class file to see the result. The compile time errors are because of the syntax. If you don't write the Java program by following proper syntax, then there will be compile time errors. But when you execute the program also, even after successful compilation, when you execute the program, there may be some problems which generally terminate your program completely. If there is some exception present, generally what will happen, you can compile your Java file, a class file also generated, but when you execute your Java program, what will happen? It
This
simply
class.
terminates the program. Yeah, it simply terminates. And to handle that abnormal termination, we use exception handling. In the first session, I have given brief introduction for exception handling, and I just give you a simple example.
Okay.
The people who already know about the basic syntax of Java can easily understand the program, but if they don't know the syntax, they don't need to bother.
Okay.
I'll share that recording with you so you can see that,
Yeah. Okay.
get some idea on exception handling. But that's just the introduction, that's not the complete concept. It nearly takes 2 to 3 hours to complete a complete exception handling concept. So I just explained just half an hour.
Yeah, ma'am. Can I know the syllabus for what you gonna teach in this?
Yeah, I'll show you. Generally, this is the syllabus I'll be covering. Core, and then
Okay.
JDBC, servlets, JSP, and Hibernate. And depending on student interest, a few of them have registered for UI.
For
And
you only. Okay.
a few students want to go with this same syllabus. But depending on the student interest, we'll plan the session separately for them.
Yeah. No. No. Cover the whole concepts of core Java, right, ma'am? Whole
Yes,
concepts of
you can
core
see the
Java.
complete syllabus here. Yeah, you can see complete syllabus for core.
Yeah.
Just the introduction, just
Introduction.
history and some of the features, and then just about the data types and operators,
Okay.
and then constructors.
Packages. Oops. Arrays. Mm.
I may not follow order, but I'll cover all the
Yeah.
concepts.
Yeah.
String handling, exception handling, multi-threading, file IO, generics, wrapper classes, state classes, and collections. Collections is a big concept. Takes 5 to 6 hours nearly.
Yeah. Okay. Yeah. Okay, ma'am. Oh, you can continue.
Just let me know. You want to go with the same syllabus or you have interest on any other topics, just let me know.
Yeah. Okay. Yeah.
Because I need to plan all the sessions accordingly.
Yeah. Okay. No problem. Yeah.
Okay. I think Mahesh is already have this document. I'm not sure whether he shared that with you or not. You can get this document from him.
Yeah. Okay. I can. I will talk to him.
Just have a review and then confirm.
Yeah. Okay.
And in today's session, we'll discuss about some other important features of Java. We have discussed briefly about exception handling, and then today we'll see what is multi-threading. Any idea on multi-threading concept?
Multi-threading means it has to be run in on any platform, right, ma'am? Either it is in Java or it is in
Okay,
it's in
that concept is
any operating system, which means
okay,
either
that
in
concept is related to the platform independent property.
okay.
Once we write any Java file, after generating the class, that class file, that should execute in any operating system.
Oh, okay.
Yeah, so that is nothing but the platform independency property of
Independent.
Java. So
Yeah.
that's why we call Java as any idea on this term? This
No.
is not related to multi-threading.
Okay.
This concept is related to platform independency.
Yeah.
Any idea on this term?
No, ma'am. No.
Write once and run anywhere.
Oh, okay.
Just write a Java program once and you can run it anywhere. So this is just we call it as just the theme of Java. Write once and run anywhere. We just write Java file once, we can execute the Java file in any operating system.
Yes, ma'am.
Can you tell me what's the reason behind that? How Java can execute in any operating system? What's the tool? What's the tool behind this property? Any idea?
No, ma'am. No.
Okay. The tool behind this is JVM. It's Java Virtual Machine. Because when we execute any Java file, first a class file will be generated, right? After compilation, a class file will be generated. When you are going to execute, you are going to execute your class file. And when
Okay.
what class file contains?
Class
It
file is
contains only
yeah,
the bytecode. It
bytecode,
contains
yeah,
only the
machine
bytecode.
machine language code.
Yeah. But bytecode is different for operating is different from operating system to operating system, right? So when a class file is generated, suppose if you are executing that on a Windows machine, and if you want to execute the same data class file, so that should execute in any operating system. So the reason behind this is JVM. JVM will generate the bytecode that corresponds to that operating system. So JVM is responsible for that. So we'll discuss in detail about the complete JVM architecture also. Okay, let's
Okay,
start.
okay.
Let's discuss briefly about this multi-threading concept. To understand this multi-threading concept, you need to have idea on this term multitasking.
Okay.
Let's take a simple example. So let's assume now you are attending to the class and at the same time you're doing some other work. If you're watching TV,
Okay.
maybe you just muted your TV, so you are just listening to my audio and you might concentrate, you might do any other work parallelly. Suppose if when you're working with your laptop, at the same time you can play audio file from the same laptop. That means you can do multiple tasks at same time. So let's take when you are working with your laptop and you are playing your audio.
Okay, ma'am.
If these two tasks, so generally,
Hello.
operating system, a simple process will be created, and thread is nothing but a smallest unit of a process. That means instead of creating one single process for handling multiple tasks, we will divide the task into subtasks, and for each task we'll create a thread. So that will improve the system performance. So that is generally called as a thread. So these threads can be used, we will create multiple threads to achieve this multitasking concept. So thread is basically used to achieve multitasking and to achieve better performance for any application. And in Java, to create the threads, we have predefined API. We have a thread class and we have a runnable interface. So as of now, we haven't discussed anything about interface, so I'm not going in detail about these class and interface. You can create thread in two ways, by extending this thread class and otherwise by implementing this runnable interface. To understand this terminology, it takes some time, like extends or implements. So I'm not going in detail about this concept. And this is one of the important features. So we can do multitasking using this multi-threading concept. And another important feature is garbage collection. Any idea on this concept, garbage collection?
No, ma'am.
Okay. So generally, when we are writing any program, we will create some objects. Everything will deal in the form of a object. We'll write simple classes in Java, and class is nothing but for every class we'll create some object. And when you are working on a simple project, so there will be some thousands of 10,000s of objects will be created, and after certain point of time when you're working in your project, some of the objects might not necessary, but if you still keep all of the objects in memory, it takes a lot of memory, and unnecessarily you are keeping all the unused objects also in memory. So instead of that, from time to time you can check which objects are necessary for further use and which objects are not necessary. In other programming language, this is completely the programmer's task. The programmer has to identify from time to time how many objects are in use currently and how many objects we need in the future. So this is completely programmer's responsibility. But in the case of Java, this garbage collection can be done automatically, and we have a predefined method for this, system.gc. System is a predefined method, and gc is the static method of this system class. If we want to run the garbage collector, so running garbage collector means we will identify the objects which are in use currently, and we will identify what are the unnecessary objects, and we will identify which objects can be necessary for future, and will destroy all of the unnecessary objects so that we can save some memory for the used objects. So this garbage collection is also one of the important feature provided by the Java API. And if we want to run the garbage collector explicitly at any point of time, so if we come to know that the memory is going out of the size, and if we want to destroy the unnecessary objects, then we can explicitly call this system.gc. but even if we call this method, or if we don't call this, internally this garbage collector runs, and internally from time to time it automatically identifies the unnecessary objects and it destroys them automatically. If any object value is null for a long time, then that object will be automatically destroyed by the garbage collector. And there are different properties to identify the unnecessary objects and whether to delete it or not. So that completely depends on the different properties of that garbage collector. So we'll discuss in detail about this. These two are another important features of Java. So one is multi-threading, so which is generally used to achieve multitasking. We can do more than one task at a time, and this concept is basically used to improve the system performance. And then garbage collection, so this concept is used to save the memory, to utilize the memory in an optimized way. This garbage collector concept will be used. We can explicitly run the garbage collector at any time if we need, and even if we don't run the garbage collector, it will be automatically done by the Java API itself. From time to time, it checks the unnecessary objects and it destroys them automatically. So these two are also the important features. And we have already discussed about the other important features, like Java is platform independent. And we have already discussed how Java is platform independent, and Java is more secure when compared to other programming languages. And we have discussed how Java is secure when compared to other programming language. So one reason behind that is we have avoided the concept of pointers, And another reason is Java is going to run in its own runtime environment. It is not going to make use of the tools of the just operating system. Inside operating system, after installing Java in your machine, so there will be separate environment will be created, that is generally called as JRE, Java Runtime Environment. So Java is going to run inside this Java runtime environment, so that provides more security when compared to the other programming languages. So these are some of the important features of Java, and we have already discussed about the basic history of Java, and we'll discuss in detail what is this JRE, what is JVM, and there is another term that we use, that is JDK, Java Development Kit. So let's see what it is first. First, we will discuss about JRE architecture. What is JRE? What it contains? So JRE is nothing but it is Java runtime environment. It basically contains JVM, and it contains some set of library files. And it contains some other files. So generally, these files will be used by the JVM at runtime. So this is the complete architecture for JRE. It contains some set of library files, and it contains some other files, some MISC files, so which are generally used by the JVM at runtime for executing any Java program. So this is the simple architecture, and JVM is a virtual machine. Generally, it physically doesn't exist. It's just a virtual machine. And if you see, after installing Java in your local machine, so there will be two folders. One is JDK and another one is JRE. So JDK contains some tools for development, and JRE contains basically some set of library files, and it also contains some MISC files. Generally, those files will be used by JVM at runtime. So in this lib folder, all of these jar files are present. So it contains some set of library files, nothing but that will come in the form of the jar file like rt.jar and tools.jar. So these are the library files. That means the complete Java API is packaged, it is compiled into that class file, and it is packaged as a jar file, and that is placed inside this lib folder. And it also contains some other files like some DLL files, and these files are generally some exe files. These files are generally used by JVM at runtime. And there is another folder, that is JDK. So JDK contains JRE, and along with that JDK contains some development tools. So it contains development tools. So this is the complete architecture for JRE. This part is the complete architecture for JRE, and this whole part is the complete architecture for JDK. JDK is nothing but its abbreviation is Java Development Kit. If we want to compile any Java program, we'll hit the command javac. That means we are going to start the compiler, and then after successful compilation, we are going to execute the Java program with the command java. This JDK contains all these development tools, and it also contains JRE. Inside this JDK, there will be another folder, JRE, and it contains some set of library files, and then some development tools like javac and java, so which we generally use for compilation and execution of a simple Java files. So this is the architecture for JRE and JDK, and let's see the important one, that is JVM. First, let's see the complete architecture of JVM. JVM basically contains a class loader. As we have already discussed, after successful compilation of a Java file, first a Dart class file will be created, and that class file will be saved automatically in our local drive. So wherever we save our Java file, at same location that class file will be created. But Java is not going to run in our local system. That means Java is not going to run in the operating system, right? Java is going to run in a separate environment. So that is generally called as JRE. When after successful compilation of a Java file, after generating a Dart class file, first the Dart class file should be loaded into the memory. That means the Dart class file will be copied to the Java runtime environment, and for that this class loader is responsible. Class loader is a tool that will copy the Dart class file from your local disk to the Java runtime environment. So this is one of the tools that is present in JVM to copy the Dart class file into the Java runtime environment. And also JVM contains different memory areas. Depending on the data that we write in a Java program, depending on the data will be saved in different memory areas. Suppose if we create some local variables, that will save inside stack, and all the objects that we created, so those objects will be saved inside heap. And we have different memory areas. There are totally 5 memory areas we have in this JVM architecture. One is the class area, another one is heap, and next one is a stack, and then we have a PC register, and then a native method stack. So this one is class area. So this contains all the data that we write in a class, and the next one is heap, which contains all the objects. It may be either the predefined class objects or the user defined class objects. Heap contains all the objects. And then we have stack. Stack generally used to save the reference variables, to save local variables, and to save some partial results. All these details will be saved inside stack. And then we have a PC register. This is internally used by the JVM. And next one is the native method stack. All these concepts are not related to programming, but it's better if you have some basic idea on this concept. So today's session is not much important for programming, but you should have some basic idea. Anyways, other students also haven't joined the session, right? So I'm covering these concepts today. These are not much important, but it's better to have some basic idea on this concept. So these are the 5 memory areas: class area, heap, stack, PC register, and native method stack. And along with this, JVM also contains execution engine. It contains one execution engine, and it contains some native libraries. And we have native method interface. So this is the complete architecture of JVM. It contains a tool called class loader, so which is generally used to load the Dart class file into the Java runtime environment. So this is the complete architecture of JVM, that is the Java virtual machine. So first tool is the class loader, which is generally used to load the Dart class file into the runtime environment. And class area, so this is one of the memory area which contains all the data that is related to the class. And next one is the heap. Heap generally contains all the objects. And next one is the stack. Stack generally contains local variables, and it contains some partial results. That means when we are doing some calculations, we might assign the result in a different variable, and we might hold the result in a different variable for some time, and then we might reassign that to another variable. Stack basically contains that partial results. Yeah, Praveen, you have any question?
No, nothing.
Okay. No problem. Feel free to ask at any time. You can interrupt me at any time. No problem.
Yeah, okay.
The stack generally contains all the local variables. If you don't know about what is local variable, just ignore it. Just remember the terms. Whatever we are discussing now, we'll be discussing in detail about the concept. In Java, we have three different types of variables, like local variable, instance, and static variables. Any idea about them?
Yeah, I have a little bit idea, man. Local variable means we will write within the methods, and the global variable means we will write in the outside the main.
Yeah, in C we use the term global variables, right? In Java we use the term instance.
In Java?
We use the term instance variable. I mean,
Exactly.
global variable is the term that we use in C, right?
Okay, man.
In Java we use the term instance variable, and we have another variable called static variable. Static variables also we generally declare outside the method or constructor, but we
Yeah.
use the keyword static. We write the keyword static. Yeah, Karishma, tell me.
Static variable is used as a global variable?
No. The term is different. Don't use the term global.
Okay.
Actually, in C, we use the term global that is actually related to where we access that variable, right?
Yes.
Yeah. But in Java, the terminology is a little different. I'll show you a simple example. The basic difference between these three variables in Java, these are the terms we use. One is local, next one is instance, and the next one is static. Properties of instance static is almost similar, but the difference is that means the location where we declare the variable and the syntax to access them is little different. Some of the properties are common for instance and static. The basic difference between instance and static is when we declare static variable, we use the term static. Both of them will be declared outside the method or constructor. I think you have idea on these terms, method and constructor, right?
Yeah.
Yes.
Okay. Instance and static both are declared outside the method and constructor. But the difference comes, to declare a static variable, we should use the term static. That means when we declare that variable, before that we add the keyword static. And another important difference is with respect to memory. Suppose I'm writing a simple class test. In this class, I'm writing a simple constructor. Just a default constructor, and inside this, I'm declaring a variable. I think depending on the location, yeah, you can easily guess the variable, right? You have idea on this string?
Yes.
Do you have idea on this topic?
Yes.
This is the simple class. I think you can easily identify which one is a local variable in this program.
Yeah, int A is a local variable.
A is a local variable because this is defined inside the constructor. Similarly, if anything is defined inside method or any block of code, block of code is nothing but in Java we have two different block of two different blocks. One is the instance block and another one is the static block. Okay, just forget about the term block. We'll discuss about that later. We use only these two terms, constructor and method. If anything is, if any variable is defined inside a constructor or inside a method, it will be local variable. This is the instance variable because this is defined outside the method or constructor. This college name variable is also defined outside the constructor and method, but this keyword static is used. This represents it's a static variable. And the difference is, suppose for this class from main method, for this class, if I create two objects, then there will be two copies for this name variable. Do you have idea how to create object for the class?
Yes.
This is the basic syntax. And suppose if I create another object, test E1. I'm just calling the default constructor. I'm not sending any parameters, but I have created two objects for my class test. In that case, there will be two copies for this name variable, and there will be only one copy for this static variable. Generally, for static variables, there will be a single copy, but for instance variables, the number of copies will depend on the number of objects that we create. Generally, using static is preferable to use to optimize the memory, because there will be single copy for a static content. And in general, static is the term that we can use for method and for a class also. So that's a different concept. If any variable is defined as a static, generally there will be only single copy for that. But for instance variables, there will be number of copies depending on the number of objects that we create for that particular class. Even though there are two objects created here for the test class, there will be single copy for this college name variable, and generally this will be shared with all other objects automatically. Other difference is if we are trying to access these two variables from same class, there is no difference. But when you try to access these two variables from another class, if you want to access this static, then you don't need to create object for this. You can just use the class name. But if you want to access this name variable, then you need to create object for your test class. Using test class reference variable, you can access this.
Okay.
So that's these are the differences between instance and static. And local, the properties of local are different. Generally, instance and static are visible to the complete class, visible to entire class. That means these variables are defined outside, right? So if I want to access these two variables from any other method of the same class, we can easily access that. But local variable can be accessed only within the area where it is declared. Suppose if I declare a variable inside a constructor, I can access that variable only inside the constructor. Suppose if I try to access this variable A from main method, then it is not possible. But I can access these two variables from a main method also. Local variable can be accessed only within the area in which it is defined. Suppose if you declare any variable inside a particular method of a class, then you can access that variable only within that method. You cannot access that variable from another method of same class. You can't even access that from another method of same class. But, instance variables are by default visible to the entire class. We can access it from any other method of same class. If we want to access instance and static variables from outside the class, then we should check the access modifier for that. Access modifier is again a different concept. That's why every concept in Java is interrelated.
Okay.
Initially, it takes time. We need to complete at least 7 to 8 sessions, then you can get the terminology. This is the complete architecture for JVM. Class loader, we have discussed class area, heap, and a stack. Stack basically contains all the local variables, and it contains partial results. And stack also contains method trace. So method trace is nothing but generally program execution starts from main method in Java, right? What are the methods that you write? But whatever the method that you call first from the main method, so from that point the program execution starts. For every method invocation, so there will be one entry that will be saved inside stack. Suppose if you write different methods here, suppose if I write void show and I have some implementation for that, and I have another method say void display, and I have some implementation for that, and then from main method, so let's assume first I have called this show method and then I have called this display method. So like this I have called the method. So for this in stack there will be one entry for every method call, and as we already know the program execution starts from main method, right? So inside stack for every program the first entry will be the main method. First entry will be the main method, and then from main method we have called the show method. So then the next entry will be for show method. From the show method if we call any other method then that will be saved after this, but from show method we are not calling anything, and after completing show method execution we are calling display method. So like this for every method invocation, so there will be one entry in the stack. So that is generally called as the method trace. The stack contains all this method trace. So it gives all the information about the method chaining of a particular class. And PC register is nothing but this is called as program counter register. Any idea on this? The people who are from electronics background might be knowing the answer for this. Program counter register. Any idea?
No.
Karishma, you are from EC, right?
No. I'm from computer science.
Okay. PC register is nothing but it is program counter register. So generally, every statement that we write in Java, after converting that into a class file, then when we execute the class file, for executing every part of program that we write in Java, it will be converted into an instruction. And this PC register contains the address of that particular instruction which is recently executed. So it contains that details. So this is not much important programmatically, but programmatically you should have some idea on this class area, heap, and stack because these are the terms that we generally use. So you can ignore about this PC register, and then native method stack. So native method stack is nothing but the backbone for Java is heap. In Java API, we have some predefined classes, right? And all the predefined classes have some predefined methods. If we take string class, can you just name any methods of string class? Any idea? Any method of a string class. String is a predefined class or user defined class?
It can be
Predefined class.
Yes, it's a predefined class. Okay. Can you just name any few methods of string class?
Add is a predefined. Add is a method.
Okay. Add
predefined class
method.
is system.out.println, right, man? That's also a predefined
No,
class.
system is another predefined class that is not related to the string class.
Okay.
Length method, append, concat, char at, index of. Did you heard of these method names?
Yes.
Yeah. Okay.
So these are some common methods. Like this, every class, every predefined class that is defined in Java API contains some predefined methods. But some of the method implementation is done in C language. when you work with Eclipse, you can see the complete implementation of such methods also. But not all, but some of the methods are completely implemented in C and some are implemented in C++ language. So all those details will be saved in this native methods tag. Then execution engine. Execution engine generally contains 3 parts.
Okay.
Any idea on this?
No.
I think the people from CSE background also might have idea on this.
No.
Just-in-time compiler. JIT compiler. So it is generally called as just-in-time compiler. This execution engine contains this JIT compiler and then interpreter. Any idea on this interpreter? So this is also related to instruction set execution.
Executes code line by line.
Yes, it executes the code line by line. And JIT compiler, so this is generally used to improve the performance. So first, it identifies the redundant instruction. That means if there are any instructions which are present redundantly, that means if they are present multiple times, so it identifies all of such instructions and it executes all of them parallelly. That means it identifies the similar task and it executes all of them parallelly, so that application performance will be improved. So this execution engine contains these 2 parts, JIT compiler and then interpreter. So this is all related to the execution part. And then it contains some native libraries. Native libraries are nothing that we have already discussed. Some of the methods are developed in C language, right? So that class files are copied into this native libraries. And this native method interface. So this part will give you interface between the methods that are implemented in C and then it loads them into the Java language. For that, this native method interface is responsible. So this JVM contains all of these tools for successful compilation and execution of a simple Java file. This is the complete architecture of JVM. This is not important programmatically, but it's better if you have some basic idea on this. Tomorrow onwards, we'll start with the programming fundamentals. We'll discuss about identifiers, data types, and what kind of stuff. From tomorrow, we are starting the actual concept. So this is just a theory, whatever we have discussed in first session and today's session. Even if you miss these 2 sessions, not a problem. But don't miss the session from tomorrow.
Yeah, okay.
Okay. Yeah.
Anything else you want to discuss?
From when will the class like be from like it will be there for 1.5 hours, no?
No, for 1 hour.
For 1 hour. Okay.
It will for 1 hour. And after a few days, I'll plan for 1.5 hours.
1.5 hours. Okay.
Actually, how many days you are planning, ma'am, for complete for whole Java?
For complete syllabus that is mentioned in this document, it takes 50 days to complete. If we can take longer sessions, we can complete it in 40 to 45 days.
Yeah, okay. 50 days is okay. I think it may complete about like December ending like that, right?
We can complete it in 2 months. I mean, for all the concepts that are mentioned in this document. If you have interest on any other concept, that will plan as a separate session, not in this.
Yeah, okay.
Okay.
Karishma, tell about your interest to Mahesh according to will program.
Yes. I'll just talk to him.
Yeah.
Ma'am, actually tomorrow I have a class, so I can't come maximum.
Okay. Anyways,
For every Tuesday, I will have a class, ma'am.
not a problem. Every class will be recording. If any student misses a session, we'll share the recording.
Yeah, okay. Yeah.
But by the time when you join next session, better to review the complete recording. Note everything. If you have any questions or anything else, better to note it.
Yeah, okay. Yeah, immediately after complete the class. Yeah, okay.
Anything else you want to discuss?
Mm,
No.
actually, you're teaching from India, ma'am?
Yes.
Oh, yeah, okay. Yeah, that's it, ma'am. Yeah.
I'm ending this session today. We'll continue tomorrow at the same time.
Yeah, okay. Thank you, ma'am.
Thank you.
Good night. Bye-bye.